Hi guys, how have you been? Please keep sending your doubts at info@scoof.com no matter how small you think the doubt is. You can write to us as many times as you want and we promise to write back immediately. You can also call at 96501-77361 for a free doubt clarification session. Alright, let's start with the topic. The second topic of this chapter is quadrilaterals. There are two subtopics: elements of a quadrilateral, special quadrilaterals. So let's begin. As we have seen in the first topic, quadrilateral is a polygon with four sides. So what are the elements of a quadrilateral? Let us take a quadrilateral ABCD. Its elements are its sides, vertices, angles, and diagonals. Diagonals, however, are not essential, but without sides and vertices, there is no quadrilateral. They are essential elements. We can see that ABCD has four sides, four vertices, four angles, and two diagonals. Sides are AB, BC, CD, and DA. Vertices are ABCD, and angles are ABCD, written in small letters. And diagonals are AC and BD. Sides such as AB and BC or BC and CD are adjacent sides which touch each other. Adjacent meaning side by side, whereas sides such as AB and CD are opposite sides which do not touch each other. Similarly, angles on the same side such as A and B are adjacent angles, and angles not on same side such as A and C are opposite angles. So what are special quadrilaterals and what makes them special? Clearly, some properties of essential elements, sides and vertices, will make them special and give them special names. Let us see how. We have a quadrilateral. When all opposite sides become parallel, it is called a parallelogram. And when only two opposite sides are parallel, it becomes a trapezium. When adjacent sides are equal, it becomes a kite. It actually looks like a kite. Now, a parallelogram can be made more special. When all angles of a parallelogram are 90 degrees, it is called a rectangle. And when all sides are equal, it is a rhombus. When all sides are equal and all angles are 90, it becomes very special, a square. So these are all types of quadrilaterals. We will now study their properties. Let's start with parallelogram. Draw two parallel lines, 1 and 2, and then draw two more parallel lines which are transversal to 1 and 2. Call them 3 and 4. So we get 4 intersection points, which make a parallelogram ABCD. Obviously, opposite sides are parallel. AB is parallel to CD and BC to AD. We use two vertical lines to represent parallel lines. If we now measure AB and CD with a ruler, we will see that they are equal, and similarly BC and AD will also be equal. So opposite sides of a parallelogram are equal. This is the first property of a parallelogram. Angle B is equal to this angle X since they are corresponding angles, and X is equal to angle D since they are alternate angles. So angle B and D are equal, which gives the second property. That is, opposite angles of a parallelogram are equal. Let's say diagonals intersect at O. We can measure and see that OB and OD are equal. OA and OC are also equal, which means that diagonals bisect each other. A and B are co-interior angles. Their sum is 180 degrees, which means they are supplementary angles. So adjacent angles are supplementary. So we have seen that in a parallelogram, opposite sides are equal, opposite angles are equal, adjacent angles are supplementary, and diagonals bisect each other. Next is a rectangle. If lines 3 and 4 intersect 1 and 2 at 90 degrees, we get a rectangle. It has all the properties of a parallelogram that we have just learned, plus one more. Its diagonals are equal. That is, AC is equal to BD. We can measure and verify. We can see that 2. Tilt this parallelogram and diagonals become equal. So now in a rectangle, opposite sides are equal, opposite angles are equal 90 degrees. Adjacent angles are supplementary, 90 plus 90. Diagonals bisect each other and diagonals are equal. Now let's move on to rhombus. All sides are equal, so draw 3 and 4 such that distance between 3 and 4 becomes equal to that between 1 and 2. If we measure the angle O at intersection of diagonals, it is 90 degrees, which is the first property of a rhombus, that is diagonals bisect at 90. Angle B and B' will also be equal. Diagonals bisect the angles too. So now in a rhombus, all sides are equal, opposite angles are equal, adjacent angles are supplementary. Diagonals bisect each other at 90 degrees and diagonals bisect the angles. Now we will look at a square. All sides are equal and angles are 90. We draw 3 and 4 perpendicular to 1 and 2 such that the distance between them is equal to the distance between 1 and 2, and we get a square. We can measure and verify that diagonals are equal and they bisect each other at 90 degrees. So OA is equal to OC and angle O is 90. And the diagonals bisect the angles, so A and A' are equal. Actually, we get the square by tilting the rhombus or by compressing or expanding the rectangle. So a square has all the properties of a rhombus and a rectangle. So now in a square, all sides are equal, all angles are equal, 90 degrees. Adjacent angles are supplementary, 90 plus 90. Diagonals bisect each other at 90 degrees. Diagonals are equal and diagonals bisect the angles. So now let's move on to a trapezium. Only two opposite sides are parallel. So if we draw 3 and 4 not parallel, we get a trapezium, ABCD, in which only AD and BC are parallel. There seems to be only one simple property. Since A and B are co-interior angles, they are supplementary. A plus B is equal to 180. So in a trapezium, adjacent angles are supplementary. Now if we draw 3 and 4 in such a manner that AB becomes equal to CD, trapezium ABCD will be an isosceles trapezium on the lines of an isosceles triangle in which two sides are equal. Now since two sides are equal, angles on same base become equal. On base AD, A is equal to D, and on BC, B is equal to C. And diagonals also become equal, that is AC and BD are equal. Let's tilt the normal trapezium for you to see. So in an isosceles trapezium, adjacent angles on parallel sides are equal and diagonals are equal. The last one is kite. Draw two perpendicular lines, 1 and 2, intersecting at O, and mark points A and C on 1 such that OA and OC are equal. Now mark any 2 points B and D on 2. Join A, B, C, D to get a kite. If OB and OD are also equal, we get a rhombus. Actually, if we stretch one end of a rhombus, we get a kite. The perpendicular lines are diagonals of the kite. Since we have stretched a rhombus, only angle A and C are equal, but BD bisects angle B and D. So B is equal to B'. Also, triangles 1 and 2 are congruent because all corresponding sides are equal. That is ABBC, ADDC, and BD. This is SSS congruency condition. Now let us see what the properties are. In a kite, diagonals intersect at 90 degrees. One diagonal is bisected. The bisected diagonal joins vertices which form equal angles. Non-bisected diagonal bisects the angles. It also divides the kite in two congruent triangles. Now here you can see all about quadrilaterals on one screen. Alright, so this chapter is over. Next week we will release the chapter on mensuration, so please like and subscribe to get notified. And click the link on the screen to watch the first topic. We will soon release the third topic of Class 6 Chapter 1 and trigonometry for Class 9. Do tell your friends. Thank you for watching. Bye bye.